Everyone, welcome to Nevin's Data Lab. In this video, we'll learn about random forest, which is basically a continuation to the decision tree video that we had posted yesterday. So if you haven't watched it yet, please do watch it and then come back over here. So what exactly is random forest? As the name suggests, it's basically a random group of trees which are grouped together. Like let's say this is our whole data set. One subset goes into this tree, one subset goes into this tree, one subset goes into this tree, and the last subset goes into this tree. The subset could have like repeated samples as well, and then in the end we group all of these trees together to get a final output. So let's say if our task is to classify, so for classification we will take the majority of all the predictions, and if it's regression then we will take the mean of all the predictions. So now that we know what a random forest is, let's jump into the code. So I've already imported our decision tree class from the previous video, which was this thing, and I've also imported NumPy, and as always I have created a class with init, fit and predict functions. So for init function we need the number of trees that we want to make, the min sample split like we had in the previous video, and the max depth. So let's like initialize each to like value. And all these which basically will store all our trees. So let's just keep it an empty array for now. So let's move into the fit function. For the fit function, we need the self, we need the x, we need the y as well, and for I in range self.entries, basically we want to create n number of trees. So we can just create tree is equal to decision tree with all the features. So we will have to initialize what else did we have? We only had these two parameters, so we have put these two. Next we have to fit this tree. So for fitting, we don't have to fit it on the entire data set, right? We just need a subset of it. So we can create a subset like this. I'll just create indexes with random values dot choice, and here it would be ensamples, ensamples. So what is our ensamples? Ensamples is basically x dot shape of 0. So ensamples is equal to, and here we'll have to put replace is equal to true. Next we can get x sub comma y sub is nothing but x of idx's comma y of idx's. So now we have taken basically the x subset and y subset, and we can put inside the fit function. And then finally we can append this to like a rf trees list. Now we have all the trees appended to rf trees. So next we can move on to the predict function. Predict function would basically be getting the majority of all the values. So for tree in self dot x rf trees. Okay, so I'll have to make this self dot rf trees because we have to access it over here as well. Tree dot predict x. So now that we have the prediction would be for the whole sample set. Like if there are, let's say, 10 classes, then for each class there would be a prediction. We can append all these trees into another just a function, just keeping the name different. Rf trees dot append tree, I mean, this would be all the predictions, right? So rf preds, let's just keep it like this, and we can convert it into an NP array. So this would be basically our predictions. So how do these predictions look? It would be like a list of list, which would like let's say there are 4 classes, so it will give like predictions, let's say like this. The next one would be, let's say something like this. If there are 2 trees, if there are multiple trees, there would be more in a list. But we don't want the predictions like this. We want the classes, I mean, for each class we need the output from different trees. So basically we need a vertical thing of this output. So for this we can like simply use np.swap axis. This will basically make the columns into like rows, and we'll have to give it this name. And now we want to get the majority. I mean, now since we have like 0 0 and other numbers, we need to take which is the majority class, that is we are getting from all the trees. So for majority I can just copy the function that we had created last time, and we can just get the majority of predictions. Final prediction for, and we can just return the final predictions. Now to test it, we can use the same code that we had created yesterday, I mean last time. So let's just paste it, and instead of decision tree this would be random forest. Let's run the code. So while debugging I found a bunch of errors. I mean, not a bunch, just a little. Firstly, this should have been 0 1 for swapping, not 1 0 like we had initially done. And the other thing was that while creating these predictions we were like creating an extra row which we didn't need. I mean, we were creating an extra list which we didn't need. So I just did it in a single line this time, and now just run and see. Okay, wait, we don't have to run it like that. We will have to run it like python 3 -m, the folder name, dot the file name, uh, as you can see we got a final accuracy of 96.45, which is like pretty good. So that's it for this video. If you like this video, please like, share and subscribe. Thank you.